Okay, let's give you guys some more practice. So find the limit of this sequence as n tends to infinity. So press pause and have a go. Okay, so to do this, break this up. So remember, natural log of a b is the same as natural log of a plus natural log of b. So break this up into one thing plus another thing, and then you've got a common denominator here. So you can basically split it up into two different fractions, and then as n tends to infinity, you can see that the cube root of n. Square root looks like this. Cube root looks something like this. But the point is, cube root of n keeps on climbing. It keeps on climbing and climbing. Well, this here is a constant. Natural log of 9 is a constant. It's a number that will stay still. This thing here will climb. So therefore, the whole lot here will head towards 0. Because you've got this thing that doesn't change, and then this thing keeps on climbing. So the overall thing will head towards 0. So we can pretty much forget about this. So now it's just a matter of us trying to figure this thing out. So this thing is this thing here. So now let's check it. As n tends to infinity, natural log of n. So natural log of n will keep on climbing. It will head towards infinity. And cube root of n, well, square root looks like that. Cube root looks like something like that. But the point is that the cube root of n keeps on climbing. So you've got infinity over infinity, so you can apply L'Hopital's rule. So differentiate this. So applying L'Hopital's rule means that you can differentiate this and then differentiate this. Because if you differentiate this, it will give you this thing here. So now tidy this up. That will then give you this. So you've got one thing divided by another thing. That's the same as you multiplying by the reciprocal. So from here, so from here, that will then take you to here. Now it's top times top, bottom times bottom, and then blah blah blah. Tidy up, it will then give you this thing here. So remember, cube root of x keeps on climbing. So you've got 1 divided by something that keeps on climbing. So this is going to head towards 0. So this whole thing here will head towards 0. 0 times 3 is going to be 0. So the limit will be 0. Okay. Next one. So find the limit of this sequence as n tends to infinity. So press pause and have a go. Okay. Remember to do this. Remember this. That's the same as root a over b. So rewrite this as. So rewrite this as this. So now as n tends to infinity, this thing here we can imagine as being n squared. This thing here is going to be n. So as n tends to infinity, we can consider this as being n. So as n tends to infinity, it's going to be root n, or root n. Square root of n keeps on climbing. So therefore, the limit here is infinity. Okay, it diverges. So next one. Find the limit of this sequence as n tends to infinity. So press pause and have a go. Okay, so to do this, well, you should n factorial versus n to the power 3 in effect. You should be able to recognize it, but let's pretend you couldn't recognize it. So when something's complicated, so when you have something complicated like this, break it down and look at the simpler version. So let's look at a case where n equals 4. So when n equals 4, you put it into here, so it would be 4 factorial. So it would be 4 times 3 times 2 times 1. And then when n equals 4, it's going to be this 4 here. It happens to be this. Well, when n equals 4, put it into the n here. It's going to be 4, 4, 4. That's this bit here. And then this 4 here is this 4 here. So now it gives you a rough indication. But let's increase n. Let's increase n. N equals 9. It will be 9 times 8 and so on here. When you look at this here, so n equals 9. So when you put this into here, it will be 9 9, 9. The question here is that as n tends to infinity, you've got a choice of increasing. You've got a choice of increasing the number of blocks here, or you can increase or you can try and make these 3 blocks a lot, or you can put something very big into these 3 blocks. But the thing is, when you look at this, sorry, I'm not explaining this very well. When you look at this, it's one thing divided by another thing. You've got to ask yourself, it really boils down to this versus this. Now, n to the power 3 means you're fixed with 3 blocks. You're fixed with 3 blocks. N factorial, well, as n tends to infinity, not explaining this very well, but I hope you can see this n here. If you increase n to, let's say, 100, let's say you make n to be 100, then these blocks you can put 100 into here, but then you're fixed with 3 blocks because of n to the power 3 here. You're fixed with 3 blocks. But whereas up here you've got 100 times 99 times 98 times 97 times 96 and so on, all the way down to 0. You see, you can see that the numerator is going to be much bigger than the denominator because these 3 blocks are fixed. These 3 blocks are fixed. So you can see that the numerator, n factorial, will be a lot bigger than n cubed. So you can conclude that the limit here goes to this goes to infinity because this is going to be much bigger than n to the power 3. Okay.